Hi everyone, hope you are doing good today. I'm going to explain discrete random variables and probability distributions today. First of all, I need to give you a brief idea about random variable and discrete random variable. So what is a random variable? Random variable is a quantitative variable whose values depends on chance. So for an example, random variable I can pick, let's say x is my random variable. It is number of siblings. Number of siblings. So x is my random variable and which is number of siblings. So siblings can be 0, 1, 2, 3, 4, something like that, right? These values, what is the special case of these values? These values are discrete values. So in this part we are talking about that discrete random variable. If a random variable consists of discrete values, we call that random variable is a discrete random variable. Okay, so that we can so that we should be able to list those values like this. Okay, let's check this example. Consider number of siblings for students in a class presented in the table. See, this x is representing number of siblings. Those values can be 0, 1, 2, 3, 4. They have given particular frequency values and relative frequency values as well. Okay, how this becomes 0.2 8 divided by total number of outcomes 40, right? This becomes 17 divided by 40, right? I think you may remember that. So when you add these relative frequencies, that value is 0. That value is 1, right? So summation of sum of relative frequencies equals to 1. Okay, number of siblings varies student to student. It is a variable. Number of siblings for student A, number of siblings is 0. For student B, number of siblings 3, something like that. It varies from student to student. If a student are selected randomly, we can do this experiment. Siblings, number of siblings of a randomly selected student, it's a random variable. It's a variable, but it's a random variable. Why? We select students randomly. Okay, this random variable, value of this random variable depends on chance. See, value of this random variable, it can be 1, 0, 3, 4. It depends on the chance. Okay, what we who we selected. Clear? Probability distribution. When we consider about probability distribution and probability histograms, probability distribution is a listing of possible values of all corresponding probabilities of a discrete random variable or formula of a probabilities. Okay, so probability distribution is a formula for a probabilities or listing all possible values for all corresponding probabilities of a discrete random variable. Okay, probability histogram is a graph. Probability histogram is a graph which represent the probability distribution of possible values of a discrete random variable. Okay, in this case you can see an example. This is the probability distribution of x. This is the probability distribution of x. When x equals 0, which means there is no siblings, probability is 0.2. If x equal 1, okay, I'll write down it here. This is probability of capital X equals 0. This is probability of capital X equals 1. This is probability of x capital X equals to 2. Probability of capital X equals 3. Last one, probability of x equals 4. Okay, these values, when you add this probability, final value is 1, it should be 1. Okay, when you plot this or when you draw a histogram based on these results, you will see this kind of pattern. Okay, sum of probabilities of discrete random variable should be 1. See, sum of these values should be equals to 1. So, this is what we have mentioned here. For any discrete random variable x, we have summation of all the probabilities, sum of all probabilities, probability values equals to 1. That is what we have mentioned here. Probability of capital X equals 0 plus probability of capital X equals 1 plus probability of capital X equals 2 plus probability of capital X equals 3 plus probability of capital X equals 4 equals to 1. Okay. Okay, check this example. When a balance dime is tossed 3 times, this is the important part, 3 times, 8 equally likely outcomes are possible. Okay, there should be 8 outcomes. Okay, 8 outcomes, right? So, first head, second head, third head, something like that. So, you can check these outcomes, we have done this before. So, let x denotes the total number of heads, x denotes the total number of heads. So, what are the values for x? It can be 0 heads, 1 head, 2 heads or all 3 heads, clear. So, use a random variable notation to represent the event, event that exactly 2 heads is tossed. So, probability of x, what should be the value? Exactly 2 heads. So, exactly simple x value, this is x equals 1, sorry, x equals 0, x equals 1, x equals 2, x equals 3. Okay. So, x equals exactly 2 heads, 2. Probability of x equals 2, number of 2 mean number of heads, number of heads. Okay. Determine px equals 2. So, exactly 2 heads, here you have 3 heads, here you have 2 head, 2 head, 1 head, 2 head, that is it. So, you have 3 outcomes out of 8. So, probability of x equal to is 3 out of 8. Find the probability distribution of x. Okay, how do we find the probability distribution of x? So, you have to write it down here. Probability of x equals 0. What is the probability? It is x equals 0, which means there is no head. It is 1 over, because we have only this case. No head mean all values are tails. Oh, sorry, all values are tails. 1 over 8. Then probability of x equals 1. Only one head, right? Only one head. You can count 1. I can see 1, 2, 3. I can see 3 here. 3 1 heads out of 8. So, probability of x equals 2. Okay, 3 out of 8. We have figured it out. Probability of x equals 3. How many 3? Just once, right? So, when you add these all 4 cases together, it should be the probability should equals to 1. See, 1 8, 1 8 plus 3 over 8, 3 over 8, it should be equals to 1. Yes. Okay. What is this one? I just forget about this one. I think there is a printing mistake. You can see that value. Use random variable notation to represent the event that at most 2 heads. At most mean maximum 2 heads, right? Maximum 2 heads. Probability of x equal, at most 2 heads mean maximum value is 2. What's the minimum value? According to this example, 0. There can be no heads. So, x equals 0 plus x equals 1 plus x equals probability of x equals 2. Okay, probability of x less than or equals 2. Since these outcomes, or since these flips are independent, you can separately consider these probability values. Okay. Next thing is mean and standard deviation of this discrete random variable. You know how to deal with this mean and standard deviation of a random variable. So now we are talking about how to deal with this discrete random variable and find the mean and standard deviation. So for this case, actually you don't need to memorize everything. You can use this formula sheets, or you can find a formula directly from the textbooks, then use that. Mean of discrete random variable we denote by mu. We call this mu equal to summation of x times probability of x equal x. This x mean same x. Okay, these x's are same. We call this term expected value or expectation. Okay, this mu we call expected value. It's just a name. Okay, or expectation. Those are the two words we are using almost all in statistics, but still you can use the term mean of a discrete random variable. Okay, so mu, if I extend this one, summation of x times probability of x capital X equal x. This means, let's say, x1 times probability of capital X equals x1 plus x2 times probability of capital X equals simple x1 plus so on. Okay, this x1 x2 x3 sorry, this should be x2. Okay, x1 x2 x3 are values like number of siblings, x1 equal to 0, x2 equals to 1, something like that. Okay, next, standard deviation of a discrete random variable. So standard deviation of a standard deviation of a discrete random variable we denote by sigma. This called sigma is equal to square root of summation of x minus mu squared times p probability of x equal x. You know what is mu? It is the mean or expectation. Okay, or you can use this equation as well. You can use either this one or this one. There is no problem with that. Okay, so you don't need to worry about these equations. You can copy them and use them. Okay, let's see how we use those equations. Consider the age of 8 randomly selected students. Okay, they have given the ages. Express the mean age of the students in terms of the probability distribution. Okay, so mean is mu. How we get that value? Summation of x times probability of capital X equals to simple x. This x should be capital X. This is simple x. This is the random value. Okay, this is the random value. Remember that. Okay. Okay, first you have to figure it out what are the frequencies of these values. 19 I can see 1 2, there are two 19s. Okay, 20 I can see 1 2 3, there are three 20s. 21 only 2, then I can see 27 just once, right? So these are the frequencies. These are the frequencies. Okay, so you can find probability of capital X equal 19. It is 2 over, what is the total? It is 8. Okay, probability of x equal 20 equals to 3 over 8. Probability of x equal 21 is 2 over 8. Okay, probability of x equal 27 equals to 1 over 8. Okay, those are the probability values. Now you can plug those values into this equation and find what is mu. Mu equals summation of x times probability of x equal x. So x, first one pick 19. So 19 times probability of capital X equals 19 plus 20 times probability of capital X equals 20 plus next value is 21. 21 times probability of x equals 21. Next value is plus 27. 27 times probability of x equals 27. Then you can plug the values and find the mu. Mu equals 19 times 2 over 8 plus 20 times px equal 20. Px equal 20 is 3 over 8 plus 21 times 2 over 8. 2 over 8 times 27 times 1 over 8. Okay, so this is the expectation or mean of age of the students. Find the next example is example 22. Find the standard deviation for the data set in example 21. So for that you have to use this equation or this equation and plug the values, find the standard deviation. Okay, I think I can use first one, right? Summation of, so that one is, let me erase this one. That one is sigma equals within square root summation of x minus mu squared probability of x equals x. So now you have these values, you can get this sigma directly. Summation of x minus mu, so each x minus mu, first x 19 minus mu. Okay, mu I will mention here as mu because I don't know the value of this one, squared times probability of x equal 19, 2 times 8, sorry 2 over 8 plus, because this is summation, so 20 minus mu squared times 3 over 8 plus 21 minus mu squared times 2 over 8 plus 27 minus mu times 1 over 8, oh this squared times 1 over 8, square root, don't forget this square root, calculate this, that's your answer. Okay, so please do these calculations again and again and try to get the answers correctly. Okay, so please refer notes and solve more problems, then without any problem you will be able to solve this kind of problems. These are really easy problems, so don't afraid when you see this kind of problem. When you practice this with these problems one by one, automatically you will be able to master in these questions. Okay, so hope you guys enjoy my video.